Okay, good morning, dear students. This is the fourth lecture of the class equation. In this lecture, we will construct a class equation of the permutation group or the permutation group. First, we need to understand about the permutation group. Basically, the permutation group are permutation group. Basically, the permutation group are the one-one mapping are the construct by the function of one-one mapping with a finite set of the elements with itself. It's mean, suppose that we have a set S and we construct a function with S to S, and the function is 1 1 1 1 on 2. Okay, then function is 1 1 on 2. The possible 1 1 on 2 mapping, the possible 1 1 on 2 mapping construct a group is known as symmetric group, and that group are represented by Sn, and it is equal to the 1 1 mapping with S to itself. The mapping is 1 1 on 2. Okay, for example, suppose that and the order of Sn is always equal to factorial n. The order of Sn equal to always equal to factorial n. Okay, and Sn is not abelian. Sn are non-abelian if Sn are non-abelian if n greater than equal to 3. Sn are non-abelian if n greater than equal to 3. Okay, for example, suppose that we take an example S3. Okay, S3 means in the group S3 we construct all the possible 1 1 onto mapping with S3 to S3. Okay, this is the we have three elements 1 2 and 3 in the S3, like this is the S3 1 2 and 3 with S3 1 2 and 3. Then this is the one, first is identity mapping, this is identity mapping. Okay, so first element of this group is 1 to 1 2 to 2 and 3 to 3. This is the identity mapping. The second, similarly, we take the second element is 1 to 1 and 2 to 3 and 3 to 2. This 2 to 3 and 3 to 2. This is second one on to mapping. Then third is 1 to 2, 2 to 1 and 3 to 3. Then fourth is 1 to 3 and 2 to 2 and 2 to 2 and 3 to 1. Then fourth is 1 to 2, 2 to 3 and 3 to 1. Then next is 1 to 3, 3 to 2 and 2 to 1. Okay, 1 to 3, 3 to 2 and 2 to 1. The number of factorial, because we have three elements, then the number of element in this group is factorial 3. It means 6. Factorial 3, the value of factorial 3, order of the S3 is factorial 3. Okay, then it is equal to 2 into 1 into 2 into 3, it is equal to 6. So the elements are 1 2 3 4 5 and 6. So these are all the elements of this type group. We have the 6 element of this type group. Okay, and also we can write these elements like this is the identity element, this is the identity element, and this element is, because this is the identity 1 to 1, so we can write this is 2 3. This is the 1 to 2, 2 to 1 to 2. This one the 1 3 1 3. This is the 1 2 3. This one the 1 3 2. Okay, also we can write this is the permutation group like this. Okay, and the operation in the permutation group are always multiplication, and similarly, suppose we want to construct S4. Suppose we want to construct S4. This is the group of element 1 2 3 and 4. Okay, and elements in the S4 are factorial 4. Elements in the S4 are factorial 4. It's mean factorial 4 is 4 into 3 into 2 into 1. The elements are 4 into 3 into 2, 24 elements. Okay, similarly S5, similarly S6 and so on. Okay, in students, this is the basic concept of the permutation group. In our next lecture we will construct the class equation of the permutation group like S3 S4 S5 and so on. we have a formula, and we have some shortcuts for construct the classification of permutation group. Okay, thank you.